Hey YouTube, it's JP Dillon. We're going to look at our first project of 2021. This is a mid-60s Zenith, and it's touted as being all-channel television. If we kind of zoom in here and look at the etching on the display. It's a 19-inch black and white. It's got UHF. And I don't know what the model is yet because there's no tags or anything on the back or on the bottom, and so we're going to crack it open and see what it is. It's kind of a cool design. If we look at it from the top, you can see the CRT bezel sticks out. It's got the built-in antennas, metal handle instead of a plastic one or a leather one. It's heavy. It's about 68 pounds, and it's lots of tubey goodness. Now, it may be earlier than 65 because it has the projector channel window, which I think they got rid of after 65. I may be wrong on that. Some Zenith gurus may want to comment on that. But anyways, the camera makes it look nicer than it really is. It looks like somebody's tried to repaint all the chrome bits or silver bits. There's lots of peeling paint here. If we come up here, we can see that this is pretty ragged looking. It was an estate sale find last year. It was like $40, and I'm in love with these little metal Zenith portables, so it came home with me. So let's get the back off and let's do the preliminary checks with the CRT, put it on a dim bulb tester, and see what it does, if anything. Alright, so you can see it's kind of beat. Somebody's repainted this. I'm not sure what that's about. I didn't even notice that until just now. So somebody's obviously put a switch in there of some kind. Maybe the original power switch took a dump. This back's been off. It's supposed to be passed through there, but it's obviously been wedged in there. So let's go ahead and take it apart. All 1/4-inch nut drives. Oh, sec for that one. That one's a wild card. The fact that it's fatter threads probably means that they stripped it out. Nope. And that one's a wild card too. Let's see here. Larger socket on that one. And then we go back to 1/4-inch up here. I should probably be noting where all these screws go because, you know, they're probably put in there for a reason. The fact that the screws were changed that many times suggests that this was a regularly serviced item for a troublesome set. It's the Yankee on the interlock. And, oh yeah. What in the hell is this mess? That's weird. So, I don't know if you can see that or if I just completely chooched it. This switch went to a terminal on the tuner, and that goes through a B resistor here. So I'm wondering, does this switch turn the UHF on and off? Maybe there was like a bleed through problem, because they've got the feed line here, which is the B line, which used to be attached to this, which is attached to that point there, going through a switch. So why did they put the VHF on a switch? That's kind of weird. Or excuse me, that's the UHF on a switch. Totally bizarro. And furthermore, the B line to that tuner, which used to be a push-on, has now been soldered on. Oh, I keep bumping the camera. Sorry, guys. Well, in any case, I need to get this switch out of here in order to get the damn case off. So you're just going to sit there like that for a moment. Get my box head wrench, assuming that that's the correct size. Hold it from the back. That's a little weird. I'm not sure what kind of cracked out idea that was. Okay, so you probably can't read that on camera because of the horrid overexposure there. Come on. So it's the 14M282 chassis, and it's yeah, definitely had some hard life. Transformer base set, as you can see there in the middle. You've got your controls for buzz elimination, vertical linearity, vertical size, automatic gain control, width, horizontal hold. Very typical layout of a Zenith chassis of this day and age. Let's crack open the high voltage cage and see how yummy our flyback looks. Again with the different screws. These guys were just like obsessed with using different screws here. I'm thinking that was done by someone else. That's a replacement flyback. Looks like a Thornton or something like that. Nice and fresh looking. He's got the silicone doping there, still very soft. Who knows when that was done? That was fairly recent. 1B3 rectifier. Or maybe it's a 1K3. No, according to this it's a 2AS2. I wonder if that's still true, or probably is. He probably hasn't changed the cup on it. Yeah. So that tells you that this was a regularly taken care of and serviced thing. The fact that it's got a fresh flyback in it is good, but it also may mean that the set's incredibly high hour and that we're going to have a dead CRT. So that's the next thing we really need to do, is check the CRT. It's hard to tell. In fact, you can't even really see it back here, but there's a Sprague replacement filter can back here. Let's see if I can pop it off the camera mount. And you can see here the famous orange label up top. All you vintage TV servicers know what that is. That's a Sprague can right there. So that was replaced. A lot of non-original tubes. You've got the RCA Compactron, you've got the Sylvania, you've got the, oh boy, the Realistic Lifetime, yeah, absolutely garbage tubes. Walk into Radio Shack with one of those if you still have a Radio Shack near you. I hear that a lot of people have kind of tried to reboot those stores on their own accord. Couple of original Zenith tubes, not much though. Let's see, probably original CRT, judging by the labels that have worn off. Alright, so the next thing we need to do is let's get it on a CRT tester and see what we're up against. Socket's nice and tight, nothing loose there. Yoke looks strange to me. I don't know what this is about. It's kind of weird. Like there was something supposed to be mounted there, or maybe it's not even an original yoke. I don't know. Anyway, on to CRT tester land. Alright, so we have our Beltron adapters using the AE5 socket A and a number 3 feeding down to the Beltron itself. Let's juice it. And let's see what we get here. Is it lighting up? Yes, it is. Watch that green meter. Nice strong CRT there. That's like brand new. Makes me wonder if you got a replacement CRT too, or if it's just like a Roland based CRT. If that's a Roland Zenith CRT, those things never die. Never seen one dead yet. Okay, well that's good. Just out of sheer curiosity, I wonder if the cleaning light comes on. Yeah. That should make it even happier. Yep, it does. If the emission's good, I'll still do the cleaning on it just to get some of the garbage off the cathode. But That's great. That's like brand spanking new. So now comes the fun part. Let's put it on the dim bulb tester and juice it. So like with any of these older TV sets, what I like to do is just disconnect the horizontal out. If it's got a top plate connection, just remove it. If it doesn't, just yank the tube out. Now if it's a series string set, obviously you can't do that, but with a transformer based one like this one, it's pretty easy. And so what I'm going to do then is, well, we're not going to see any light on the screen yet, so I suppose I don't need to rotate the set. So I'm going to get about a 100-watt bulb, and we're just going to give it a kick and see how it behaves. So I'm going to stick the dim bulb tester over here. Be like a Glade man and plug it in, and get my cheater cord. It's hanging around here. And just go straight in. I used to have an actual interlock plug, but it's the plug portion of it started deteriorating, and I thought, this is probably not going to be safe anymore, so I used the alligator clip line instead. Let's go ahead and plug this in. And usually the volume control is also the switch, so let's go Yankee Yankee. And that switch is stuck. Like really stuck. It don't want to move. Alright, so if that's the case, we'll unplug this a little bit, give it a shot of deox. There are lubricants in there. See if we can work it free. There we go. Man, that thing was sticky. Alright, onward ho. That's a good sign. Bulb's getting dimmer. We'll see if it brightens up as the tubes warm up. Yep, starting to get a little brighter. I don't hear any vertical or anything like that, but it's probably not enough voltage with the current limiter there to start anything. Now would be a good time to check plate voltages and see if we have our B boost. Or not our B boost, but rather our B plus. So I'm just going to hang one side to ground here. And then I stick my probe underneath the top cap, and we have voltage there. It's going to be really little with the dim bulb tester on there, but the fact that there's B voltage here says that our flyback primary isn't open or shorted, and that our power supply is running, so that's good. So what I'm going to do is we're going to let this cook a little bit, and then we're going to come back to it and in about maybe 20 minutes or so and see if any of the cans are getting hot. We'll get an infrared thermometer, check that can, the one in front of the CRT and the one back here that's been replaced, and we'll see if any of them are getting warm or hot, which would indicate that they're leaky and need to be replaced. Maybe dust out the chassis a little bit too. And then we'll come back to this one and take it off the dim bulb tester and see if we get vertical start, and then we'll see if we get sound. Right now, I do hear a small hum from the speaker, but no static or noise or anything. Like I said, there's not enough B voltage to let this thing run on the limiter. So we're just going to wait a bit and then we'll come back to this thing. Alright, so it's been a little while. Let's just come over here. And right now that can is just above room temperature in here. It's a little chilly this morning, so about 60 degrees at its hottest point. Let's come over here. The one over here is 53 degrees. It's even colder. And I'm just going to zap the one back here. Again, 59.5 degrees. So, yeah, it's cold here this morning. It's about 50 degrees out. And we don't run the shop heater that much, so it's cold in here. But anyways, yeah, nothing's heating up. And just to show here, not much B voltage. Well, that's not conducting, so the vertical's conducting. We're trying to. You can see 116 degrees Fahrenheit. That's at 160 B, 119 degrees, 90 degrees. So, I mean, there's B voltage there. Things are trying to conduct and run. But I think we're at a point where we can just take this off the limiter and then see if we get vertical start or if things smoke. We'll find out, won't we? So I'm going to take it off this and just go straight into the line. Hear the transformer buck there for a second. Let's see if we hear any vertical. Nope, no vertical. I don't hear it running. Got sound though. Let's see, we come over here and adjust our vertical hold. Nope. We should hear the verticals singing. 60 cycle, 50 cycle, whatever it is. Something's getting hot. I can smell hot resistor. Yet it wasn't drawing scary amounts of current. Our damper's out. Look at that. The damper's cold and dark. Maybe that's why our B won't start, or for the vertical. I doubt it. Something getting really hot. I can smell that hot resistor. So we're going to power that down. I wonder why we don't have any. Maybe it's just a bad socket. Let's try that again. There we go. Now it's lighting up. There's our vertical. You hear that? Maybe you can't, but I can. The hot smell's gone. Alright, so probably the vertical output transformer was getting pissed off that there was no sweep. because I don't smell the hot resistor now. We're going to take the bottom cover off really briefly and just take a look underneath. But the fact that the vertical's running now is promising. I think after we do a quick examination, we can fire this thing up and see what it does. But let's take a look underneath first. So already this is kind of promising. We can see some orange drops here, although that's really sloppy. We're going to fix that. Just hanging in space there. Another spray replacement can. So that's good. Let's see if there's any more surprises here once we get this apart. Just pop the feet off. We should be able to get the bottom cover out. Got one replacement foot. You're gonna come off. There we go. So yeah, definitely some work done in the past here. Sloppy though. Definitely sloppy. Okay, so a lot of those bumblebees were replaced with orange drops. Just the workmanship was kind of shoddy. Another replacement filter can. This is interesting here. Yeah, it's secure. I don't really like it. Might put a bead of glue or epoxy down there just to reinforce that. But let's get up close and personal with it and see what was done here. I don't like this workmanship. This is when I see these high voltage things flopping out in space like that. Just no, 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 no. Shorten those leads and tidy that up for sure. And he J-hooked it, but barely used any solder. It is loose. That could have also been why our vertical didn't start at first, because that's your vertical hold pot right there. Let's see what else here. Maybe he replaced the integrators too. A lot of work was done on this set, but it looks like it was definitely rushed. Like maybe this was the last days of house calls and the guy just shotgunned everything and said good luck. You can see the workmanship there where he replaced the flyback. Just electrical tape. Not sure if I want to just leave that as is because it's still holding on and it's still intact, or if I want to replace that with heat shrink. But for somebody to put that kind of time and money into this thing, I mean a new flyback on a set built in the 60s, and then new filter cans, and then all this work, somebody really loved this thing. They held on into the bitter end. And for all we know, it was still working fine when it was put away. I mean, it wasn't a estate sale. The guy was in his late 80s, according to the estate sale people. So he could have bought it new for all we know. And he just didn't want to part with it. It's another old Sprague Atom dry electrolytic. Those almost never die. Cardboard looking thing is scary looking, but it never dies. So I think what I'm going to do is we're going to make some corrections on these ones with like really long leads. I don't like this here. I think this is sloppy. I think this is conducive to failure because of the vibrations and stuff that occur when you're transporting it, or just thermal cycling that will weaken those stressed joints. Definitely going to add some more solder to that. Clean all the pots and switches. And then maybe just run a quick ERSR test before we do all this stuff on these cans. The cans are probably fine, but I'm going to check anyways. I mean, he did an okay job on replacing the cans. It's soldered to the chassis there. It's not done shoddily. The soldering work on the cans is okay. He only used like one section here, but the other sections don't have solder on them, so I wonder if this is something that he yanked out of another set and put it in here instead. We'll have to check that. But yeah, this is like, somebody really loved this thing. Okay, let me grab the ESR meter real quick and just do a brief check on those cans. I mean, they weren't getting hot or anything, but let's see if they're still capacitors or if they're just gonna open. Yeah, let's just see here real quick. Yep, continuity to ground with the cans good. That's good. That's good. That continuity ground's good. That can's good. Let's see, there's another one up here. Continuity ground's good. That one's a little tired, but it's still hanging in there. These are low values. I think these are 20s and 40s. That one's pretty close to being dead. Of course, I'm not sure what value these are. I think this is a 20 and a 40 or something like that. That section's pretty tired. What does that feed? Da, 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 da. That could be your vertical output right there, so I might check that and replace it, see what value it is. Yeah, that cap's good. So maybe figure out what values those are and just kind of tack something in there. Not like this, of course. Alright, so the main key interest here really is cleaning up this workmanship. So let's see if we can zoom it in a little bit. Yeah, let me move this. But you can just kind of see how sloppy that is. I don't like that kind of slop. Okay, so we're going to shorten those leads, redress them for sure. And this shouldn't be too hard considering what's still tacked in here. Maybe he just didn't have a hot enough soldering iron to do it. I don't know. Alright, so I'm going to grab a hold of this. He J-hooked it though. So he had some idea about making an okay connection, but I would never have let it hang out in space that much. So, first thing we're going to do is cut these leads down for sure. We're going to cut it way down. So, this is how short it is now. About 3/4 of an inch. And we're going to scrape off any oxide that might be on the leads. Just using an X-Acto knife. And then what we're going to do is make new hooks. And attempt to install it here. So I'm going to grab on with my hemostats. When you're doing this kind of work, hemostats are like the thing. You really should have a good set of curved hemostats when you're doing this kind of work, because my fingers are too fat to get into this space. So I got it gripped with the hemostats as I solder it into the lug here. And don't blow on your solder work. Let it dry on its own. If you cool it too fast, it oxidizes and then things don't work right. So now we're going to tuck this in, and the camera's going to shake because I keep bumping it, and we're going to clamp over the J-hook. solder it. And the reason why I'm doing this is because I don't like sloppy work. And if you think about it, the parasitic oscillation that we saw when we flicked that capacitor over time, like this one, any kind of vibration or anything like that, moving it or whatnot, are going to fatigue those joints. And I know the theory is if you never move the set, it's never going to be a problem, but people move things. So there's one of your integrators there, which looks original. So he hasn't changed those. We'll have to see how well the vertical behaves, because integrators do die on these. Let's see here. This one I may just leave alone. It's soldered well enough and it's not loose. It's not flopping out there in the open like these other ones are, so I'm going to leave that one be. That one's got a secure connection. This one not so much. So we're going to get up in here. Oh man, that was like barely hanging there. Didn't take much to get that loose at all. And then again, we'll shorten these. This one I need to make a little bit longer because there is some crowding, so we'll make these about 1 inch long. And before we attach anything, we'll look at that. That looks okay. Alright. I'm a little concerned about this one given its proximity to other points which it could short out. So I am going to put some heat shrink on these leads. If you're in a high density area, it's a good idea to do that. I know a lot of you may be skeptical as to why I'm doing this work before I even know that it's capable of producing a raster yet. But I have learned in the past that if you do not take care of sloppy workmanship and ignore it, it will come back to bite you. So when I see it, I like to be thorough before I put the silly thing back together. So I'm going to hook it on this side first so that I have an anchor for it to hold on to. I know the camera keeps changing its exposure. That's exactly why having hemostats is a good thing. Let me just put this back up in here. Doesn't help either that the camera's kind of in the way for the workmanship, so I have to kind of go around that. Let's solder that up, let it dry. Dry, harden, whatever. And then let's do the other one here. Come on, buddy, cooperate. There we go. You always want a nice, strong connection there. Last thing you want to do is go hunting down for loose connections. Alright, so that's 2 down, 3 to go. This is our next lovely blob here. Man, it's good that he J-hooked these, but like some of these connections thus far have been like really crummy. Doesn't take much to break them loose, which again goes with the theory about fatigue. So I'm going to cut these ones short and heat shrink this too, because again, proximity to high voltage potentials. And I've even made my own mistakes where I've been moving around inside the thing and I move some component just a tiny little bit, and then you see the sparks and then the smoke and you go, well, crap. So I'm not going to let that happen. Better to err on the side of safety. Okay. Suspicious activity in our parking lot this morning. I can kind of see the back door out of the corner of my eye and people pulling in and out of here. Drug deals. All right. Let's do the other one. Alright, that one's happy. And we get to go to this Slop-O-Matic. That's just special. I hate seeing that crap. That's just being lazy. That one fatigued the hell out of that joint. I think as a precaution, I'm going to drop some solder in there. Because all of those connections in that hole there feel loose because this thing was flopping around. Get a good shot of my solder there. That frickin' phenalic's cracking there too. It's getting little stress cracks around there. That's why I don't like working with these, well, when they were new they were fine, but this TV set's old now. And phenolic gets old and it cracks. Like here's another one. Here's another shitty connection. Excuse my language. When you work on these things enough and you see the work of previous people, you kind of go, water. Why did you do that? Okay. All right. Make sure no other surprises are afoot here. And then we'll redo this one. I know I'm probably like totally boring the crap out of you people, but this is really what you got to do. I like being a little more thorough. And I'm debating whether I want to deal with the flyback redressing, because it is holding and it's working as far as the connection is concerned. So I don't know. I don't know what I want to do with that. Thinking about it. Let me just add my J-hooks here. And we'll get this thing up in here. Yeah, that's the fun part, is trying to get all this to stay there while you solder it in place. Okay, almost there. All right. And we'll come up in here and solder this guy. And then the same over here. Still not too happy with that. See, that wire there is fatigued. So let me scrape this and this. We'll put the adjacent leads together and solder them together for reinforcement. That way it's less likely to go wiggle, wiggle, wiggle. Much better. Definitely better. And then we can do the same to this one. Scrape this, get all the oxide off, and then solder it to that joint down there so that we can enforce that a little bit better. Okay. Much tighter, no wiggles. This one actually is okay. I think I'll leave this one be. Alright, we'll come up here to this guy, which obviously needs some more solder there since that's just barely hanging on. Okay. Very good. Just tuck that out of the way. Cool. Alright, so let's get some deoxit in there. Clean all these pots and switches. There's this like big discussion right now about how deoxit is like a horrid thing that destroys controls. I have yet to see that. Contrast is up all the way. Oh yeah, there's one more cap down there I need to change. We'll do that in a second. Clean vertical hold. And then let's clean all of our size pot, AGC pot, width pot. Vertical size yet cranked. It's interesting. I'll set that at midpoint. AGC was just 2/3 of the way in. And then we got width, which is about 3/4 of the way to max. Alright, and then let's see here. Okay, so that guy right there. We're going to make him a little bit safer. No J-hook or nothing, he just stuck that on there. Neither there. So that was even sloppier. Maybe it was the same repairman that got called out to the house so many times he just got sick of it. I've seen that. Where the dude just gets so sick and tired of working on the old television set. Or maybe he's a salesman and he wants the guy to buy a new set. In any case, I'm glad he held on to this thing. Just gotta move the Get some of the old solder off of the capacitor. Yeah, okay, that's how we're going to do that. Scrapey, scrapey. And realistically, I'm not going to leave the leads long on this one at all. Let's just check and see this first. Okay. So we'll get a little bit off of here and then we'll heat shrink that lead. Just measuring it with my eyeballs. And then we'll hook this thing over like this. Come on now. All right. Okay, so that takes care of the sloppy capacitors. There's a 0.033 bumblebee right here that has to go. It's high voltage from the width control. That's just going to explode. These things are bombs. So let me get another 0.033. All right. Let's see if I can get the old cap out of here without destroying this pot. Maybe, maybe not. Clink. Everything's going to bounce around a little bit. Sorry about that. Alright, now we can get the remainder of the solder slop off of here. Seriously? Come on. Alright, there we go. Now as far as the other end of that's concerned, that's a plastic socket down there. And because I don't want to risk the socket breaking or anything, I'm not going to try to attach it there. We're just going to cut it and J-hook it like the other ones. Okay. Like I've been saying, guys, hemostats make quick work of this stuff. then add a heat shrink to that, since it's got to pass through that near the body of the potentiometer, which would be bad if that took a crap. Or passed near the body of the potentiometer, such that if it shorted against the body, we'd have a problem. Okay. It's nice and happy in there. Alright, so for now, there we go. Workmanship looks a little better. This wrap is all tight on here and it's staying there. It's not coming off, it's not moving on the wire. I'm just going to leave it be. He's got quite a number of turns, looks like 4 or 5 turns per, so it's probably safe enough. I'm not worried about it at this moment. This little thing here, it moves the tiniest little bit, but otherwise he did okay there. I'm going to run a bead of glue down that, and then we'll check up top here. Let's see, we wanted to see what the value of those couple of capacitors was, if we can even read that. Of course not, it's on the other side. Let's see, let me go grab a inspection mirror. Let's see if I can see anything. Part numbers. Yeah, that's tricky. Let's see, is that the voltage rating or is that the microfarads rating? I can't tell. That's the voltage rating. Okay, so the triangle is 4 microfarads. The blank one is 25 microfarads. And the square thing, I can't see because there's wires in the way. Let's move this out of the way. I'm going to be able to see what's going on here. That doesn't help me much. Yeah, this is what I hate about working in cramped areas like this. I can't frickin' tell what that is. Well, anyways, what was the section that was dead here? That was the square thing, I believe. The square thing was dead. And of course, that's the one frickin' value I can't read, because it's tucked up against this. So everyone's going to get motion sickness for a second while I move these wires aside. Okay. Let's see if I can... Another 4 microfarad at 350 volts. That's your boost cap right there. Okay, 4 at 350 volts. So they're all 4 microfarad capacitors, except for that one that's a 20. Yeah. So let's double check here again. Yeah, just out of curiosity. Yeah, that would be your 20, your 4, and your 4. So this 4 is reading 7, and that 4 is reading 30. So that's definitely dead. Alright, so I should probably change those two, just because. Oh, and you got that one up there too. No, that was the 4. wasn't it? Damn it. We had 4, 4, 25, and something else. Can't read, and I don't have a service schematic with me. And I need 2 hands. Hold on, guys. Okay. So this value here, that still looks okay. That still looks okay. But these sections here are no good. That tests weak, and that just tests outright bad. So let me double check here again really fast. Let's see what values I'm looking at. So it's the triangle and the the triangle is the 4, the square is the 4, and the hump is like over here and I can't read it. Yeah, so anyways, square is the 4, triangle is the 4. So we got triangle, and we got the square. So those are both the 4s. I have some 10s at 450. I think we'll just stick those in there. That should work out okay. All right, so the way that I'm going to deal with this, we're going to do 2 10s. Okay, let's get this out of the way. This out of the way. This is going to be fun. This is that cramp thing I was talking about. Let's follow this lead back and see if we can attach it somewhere away from the can area there. Alright, so that lead goes way out of the picture here. So we can probably just deal with that another way. This other one here is for the AGC that was like really dead. So I want to cut this one out. I know, right after we did all that work, I should have like paid more attention to that, but so I'm going to strip this lead, and then we're going to remove the hook that we just did. Go figure. It's not going to come off now because my work was too good. Things keep slipping. There we go. All right. So I am going to anchor the negative on the capacitor to the can anchor over here, because we know that one part of this can's soldered to the chassis, so there is a secure ground there. It's so hard to do this with the camera up close because you can't really see anything but my giant fat hands in the way. So I'm going to solder the negative lead directly to the tab of that can. And that's going to be the anchor point for that can. And then we got more heat shrink. And I'm going to come up through here. like that. That's part one on the attachment. And then part two, we're going to leave a little bit of that hanging there. And hook this. And hook this. And then solder that in. Alright, so that's one capacitor there. That's in there nice and tight. And I can do the same thing with the other one if I like. I got enough room here for that. So maybe I'll just do that since I got the room. What you don't want to do is be a dumbass and solder the capacitor on top of the dying one. That's not very smart. And again, move this out of the way a little bit. I'm going to anchor the negative to the can. Oh, that's one of the tabs that doesn't have a hole in it, a loop hole. So let's try something else. Yep. Dash that. We're going to go on the back side of this other tab. And see if we can't tuck this inside of here. Clamp that like that. Wrap it around that. Come on. All right. Solder that in place. Not a fan of this rig, but all right. Let's make sure that took. And then, now that we got this here, trim this back a little. Trim this back a little. Let's see here. Trim that back some more. This camera is too close to the work, that's why I keep bumping it. And then we'll make our little hook. And then we'll get a piece of shrink tubing to put over this, since it is going to be near hazardous voltages. I wouldn't say near hazardous voltages so much as it's, hey, it's going to be sitting next to ground. Alright, and we'll slip the heat shrink over that. we'll secure all of our heat shrink leads. Alrighty. Now I'm happy with where that's at. Now we can see, fire it up here. Check all my work. Make sure I got the caps with the correct polarity. Alright. We're good. Let's fire this thing up and see what happens. But before I do that, I want to take this silly switch out of the UHF circuit. I have no idea what the purpose was behind this. But it's going to go bye-bye. People do weird things. And when I see weird things like this, I kind of go, why? I'd rather find out later down the road. And so let's just put this back in here. Gotta put the heat shrink on it first. Let's see. Where did I put it? That's always the question of the day. Here we go. Okie dokie. Now we can put this back together. Solder it up, cover it. Because that is weird. Almost like maybe there was interference generated by the UHF tuner and he wanted to turn off the B voltage to it or something. I have no idea. Mysteries of the universe. So let me get the heat shrink in place. And then we'll just go ahead and refit this back to the UHF tuner. It sure is a weirder one. Never seen that before. Okay, so we're all kind of put back together in that regard. Guess the final thing to do is to fire it up and see if we get a raster. This is the exciting part. This is where we get to see if it flies or if it fries. Make sure that the top cap's back on the horizontal out. That it is. Let's just tuck this back behind here. Make sure that's off. And let's turn off the lights and see what she does. Channel projector ain't working right. It's off center and blurry. Here, static, that's good. Vertical. Ah. A raster. Lots of digital on the UHF band. Very cool. So we got something. That's good. Let's check our we got contrast, got lots of brightness. Our video peaking control, which is meaningless right now. Take a look behind here. No red plating of tubes or any of the crucial components. Okay. So the next thing we do, hook a simple signal source up to it and see if it is capable of displaying a picture of some kind. Let's see. Got to check and see what terminals are which because I can't read it from here. VHF one's closest to me. Yep, I can hear that's producing a change. So now we got that going on. Let's see here, simple crosshatch. So we have vertical roll. So let's adjust our vertical oscillator. There we go. And it's at an extreme range because our size and linearity aren't fixed yet. Let's adjust our horizontal hold. Oh, we can't because the slug's broken. That's great. That's just lovely. So we can't lock in our horizontal hold because the slug's broken. So we're going to have to come up with a means to fix that. But on a good note, it does produce a raster with fair brightness and contrast. The peak picture control is working. So that's where we're at after investing this time in it. But it's got a good CRT. Someone's replaced the flyback. We've got a couple of capacitors in there to replace the dead electrolytic can. And yeah, so that's going to be it for part 1. Part 2 will address the horizontal hold control and see if we can find a tool or something to get that core moved so that we can at least obtain the correct frequency response. And then see if we can't dial in the picture. The tuner is a little bit dirty too. Not unusable. It's trying though. It really is trying. Maybe we'll check a couple tubes too, but that's for another time. Hope you guys enjoyed this first part of the video. Stay tuned for part 2.